Thank you.
Um, so today we're going to be going over the style transfers, but first we're going to talk about the final project, which is starting today. Um, but before any of that, I want to talk about this poll. Thank you to anyone who answered this poll. Um, I'm pretty happy with this. I think this is at the upper edge of the difficulty that I'm happy with, which means that in the future I will not be making this class any more difficult. Won't be adding any content basically because it's kind of a sliding scale of um, when you add any more information, when you try to cover more, it's gonna get harder. There's not much you can do about that. You can take steps to minimize how much harder it gets, but you can't stop it from getting harder. Um, but I think what this poll is telling me is this is the stopping point, and then we need to start. Any other optimization needs to be in making it easier to learn these things for the rest of the time. So thank you for giving me this information. It should help. And if you have any more micro ideas on what specific things we can change in this class that you've seen so far to make it a little easier for everyone, to make it easier for people to understand, my email is open. Um, so yeah, good information. I actually have another poll up too, uh, right now. If you want to go give it a look, it's which lab you like the best. So far, I think everyone who's voted has voted for style transfer. So that's interesting. But now we're going to talk about the final project. Oh yeah, and GANs. So GANs was due today, but I decided what we're going to do for that is if you turn it in today, you can get 3 points extra credit. And if you can't turn it in today, that's fine. You can still turn it in by Friday, and you'll get full points for it. So, with that all said, we will get into the actual final project. So, this is going to take up the rest of the semester for us. Um, your goal here, your basic idea is create an advanced neural image processing project. Uh, so, important pieces here. Advanced needs to be kind of cool. Neural nets, image. It should have something to do vaguely with images, though some of the options we're giving here actually don't. So that this is the looser word. um, this will include a 10-minute presentation or slightly less than 10-minute presentation, preferably. That we'll be giving in the last day of our classes. Uh, we'll be writing a 2 to 6 page write up. Just so you're aware here, 2 is totally fine. If it covers everything, 2 is totally fine. Um, just try to get it less than 6 because then it's going to be a pain to read through it, the whole thing. But yeah, small report, doesn't need to be super structured or anything. Just a good overall view of what you did and your results and all of that. As well as a 1 paragraph summary of that, which we will be putting on our archive of projects. And the project should be fairly ambitious because the way we're going to be grading this is not on if you succeeded, but on the quality of work, the written deliverables like the presentation and the write up, and the methodology. And we do that because we want you to try stuff, and sometimes stuff just doesn't work. A negative result is still a result. So that's what we're going to try to look at more than if it worked out. Um, there's a bit of a timeline we're going to be following. From now until next week, November 4th, your main goal, first of all, you could take a couple days to decompress from the rapid fire labs and stuff, and I'm sure this is probably second midterm time for a lot of people, so take a little break. But after that, decide on a group. This should be a group of 2 to 3-ish, but if you want to have a group of 4, that's fine. And as I've said previously, if you really, really, really want to work in a group of 1, that's fine too, unless a lot of people do that, in which case I'll have to then just say nobody can do it because we're going to run out of time for everyone if that happens. So yeah, don't tragedy of the commons yourself. So you can use the Piazza tool, the group finder tool. That's up there. When you do that, if we're going to go over some project options, you can also do a custom project, but the project options are also really good. So if you're really interested in one of those, you can put on there that you want to do that. If you're just vaguely interested in one part of a topic, then go ahead and put that up there. Just try to give some information on what sort of thing you'd be interested in on that tool. And then you send me a simple project charter telling me just who's in your group, what problem you're doing, how you expect to divide the work, all of that, and some resources that you might use. Doesn't need to be super expansive, just so I can go look through my email and see, okay, who's working on what. That next week, mainly you're going to be doing pipelining and research. So, and again, this is going to depend entirely on what sort of project you're doing. Sometimes this step isn't going to really play as much of a role, but I want you to think about the second week as being research week and looking into it and designing and that sort of thing. It doesn't need to be as much actual building a model and fine-tuning as much as it is trying to understand what you're doing and getting the information you need. And that should be pretty extensive as well, which is why I have the asterisk here going on. Should be lots and lots and lots of research so that you know exactly what you're going to be doing once you start coding. And each of these Wednesdays, obviously feel free to come to class and we can talk a little bit there. We're still going to be having lectures for the rest of class, though they won't be quite as focused. It's mostly going to be just more information that can help you learn a bit more, and especially in other areas that we haven't talked about yet. But send me an email at the very least to give me a check-in of what's happened so far. And as I think we say over here, you should be getting something done every week. You can have your not as productive weeks and your very productive weeks, but there should be progress being made every week. And until the very end there, it's just going to be working on the project. It's going to be improving it and preparing it for its final presentation. And finally, on that last week, April 22nd, or April, there's no April here. Okay. November 22nd, you're going to December 2nd. You're going to do your final optimizations, make sure everything is in the GitHub and properly put in there. And also, one thing I've seen people do a lot, but don't do this because I'm going to start asking hard questions henceforth. Don't upload to GitHub from one guy's GitHub account. That defeats the purpose of the GitHub. I want to see if you don't have a GitHub account or anything, just make one, and then both of you upload your specific contributions through that. I want to be able to see what each person was doing on there and what kind of niche they were playing in the group. Once you're finished, turn-in is going to be here. In this case, what you're going to be doing is going into this document, which, I can open that up real quick. Those are the old ones. There it is. So you're going to go in here, and you're going to fill this in. You can put your link to your Git, make sure it is a public repository, link to your report, who is on the team, name of your project. We've had some funny ones in the past. And then a short description, and this is going to be where your one paragraph comes in. So your report is just going to be linked to your paragraph here. And the paragraph should just be enough to, like an abstract to a paper, to just be like, okay, so this is what this project was. You can also put that in the README for the Git if you want. That's put that extra layer of professional on there. Back to this. So, and we're going right back off of here again. So, final project ideas. You got some options here, and this bar is in the way again, and I don't know how to get rid of it. It's very sad. Can do this, then I can do this and look for it.
You can also use Control Tab to switch between them.
I could do that, but I don't know which one has it right now. Did I not open it? Why didn't I just open it from the slides I was just in? I'm questioning my own abilities here. Very sad. No, I don't want it open that way. There we go. We did it. It was quite an effort. So here are your options. The first one, of course, is just a custom project. If none of these, if you don't really care for any of these, or if there's something you particularly really want to try, that's totally fine. Just go ahead and tell me and Gustavo that, and we can clear it. You clear it with us, and it should be good to go. It can be a more scientific project where you're trying to learn, doing some sort of research to learn about how something works. It could be more of a engineering one where you're creating something like an application or a machine or something that is using these neural networks in an interesting way. We don't really care whether you're taking that more scientific or engineering route as long as it's interesting. It just can't, and it can't be any sort of like a simple version of what we've done already. No classifiers that's just classifying something. No GANs that's just making some image. We've already done that. Now that doesn't mean you can't use classifiers or GANs, but they should be in service to something more interesting than that. Push yourself. It'll be cool. And again, yeah, they don't need to succeed. They just need to be strong in methodology work, report, presentation, all that. And then if you don't have any sort of specific custom idea in mind that you want to go with, we have a whole lot of options here to pick from as well. So image captioning is a great one, using a autoencoder that has a convnet on one side and an RNet on the other. What you should be doing is, or you can also use a pre-trained model too. That's allowed and might make things a lot easier for you. You should be able to describe an image based on what that image is. There's a lot of data sets you can use. I suggest the COCO data set. That's a pretty good one. That includes those descriptions. So that'll be kind of difficult because you had to learn a little bit more on RNNs, but it should be pretty doable. And if you need help, Abhishek, I can get you in contact with him because he does these language things quite a bit, so he can help you there. And same goes with that for the VQA, visual question answering. So this is going to be, this is a harder one too. Sort of. So this one's kind of more open-ended. This one is, take a look at this GitHub repo we have. This is about visual question answering. So they're taking an image and they have to have the neural network answer questions about it. So what basically we want you to do with that is learn very much how to use this repo and eventually decide on a change for it. Decide on something you can do to make it different. And for this particular project, and this kind of changes the timeline, but all these are going to be slightly different. What you'd want to do here is not necessarily figure out on the first week what you're going to be doing to the GitHub repo. This is going to be more, okay, I need to learn about this repo first, and then think of some small change you can make and see if it ends up improving the results. So that's one option. There will be some pretty unique challenges to that, but again, you can talk to Abhishek and talk to me, and hopefully we can figure something out. It's a cool idea, but yeah. Image filter. This one is, well, it's a Snapchat filter. See if you can make your own. Use a neural network to recognize different facial features like eyes or a mouth or anything like that, so you can paste an image over it in some sort of way. We have a data set for you there. This one's pretty straightforward, but kind of fun, interesting idea, and if you really like image manipulation stuff, if you're a big Photoshop guy or whatever, this is a cool idea, fun project to do. And it has its own challenges, so that's very good. DQN. So we have not talked about reinforcement learning yet. I think we're doing that next week, actually. But reinforcement learning is a thing you can do that makes it very easy to do things like play games, having a neural network that can play games like Atari or chess or whatever. And there's a specific algorithm in reinforcement learning called a DQN, and this option is go ahead and make one that runs on Atari. It's going to take in the actual screen of the Atari game, so the image of the Atari frame as input, and then you'll have to react based on that. So that's an interesting one. You might have to, you might have to do some of your own research to start on this because we don't have the lecture this time until next week, but it's a good option, and I can definitely help you on this because this is one of my main research areas is reinforcement learning. Key bidding recognizer. This is one I've had on here for years and no one's picked it. And I kind of understand why, because it seems like kind of a pain. You have to make your own data set. But it'd be a cool idea, especially for those who watch DEF CON videos religiously, like myself. This one is, you get a picture of a key. This can be like a physical key that you'll just have to open doors and stuff. Can you, from that picture, figure out the bidding code for that key? So what are the different levels of that key? You would probably have to make this not just any key. You'd probably have to make it like a certain brand of key or something, because they sometimes have different numbers of bidding codes and everything. And the tough part would be getting a lot of keys to make a data set. But cool project, cool idea. If you can make it work, I'll be impressed. Here's another kind of on the more open-ended side ones. We have genetic neural net. So in this one, I haven't talked about genetic algorithms because this is not a genetic algorithms class, but really cool things, really neat idea. Maybe I will sometime just for fun, like a little quick one. But in this, what we'll want you to do is use them instead of using backprop and using a gradient descent to change your weights. Use a genetic algorithm to optimize your neural net. So it's still a neural net structurally, but it's not using the calculus of backpropagation. It's using this other kind of method that's a bit more biologically inspired almost. And then once you have that working, try running that on MNIST or CIFAR and see if you can get some good results, because that would be interesting. Um, this is almost the project I'd pick if you feel like you're not going to have any time and you're like, okay, I just need to get a decent project out. Because this one I think you can do fairly quickly. Um, that said, I'm still expecting a pretty good degree of effort into it, but it's a good one though. It's a fun and interesting one, especially because genetic algorithms are really cool. Pint add-on. So we have a library at Purdue called Purdue Pint. Pint is not TensorFlow, is what that stands for. And it's a really simple neural net library that Sri and Anthony actually spearheaded in making about a year or two back. So what we'd like you to do with this is to make this library, or to not make it, to add to this library. Learn about the repo we have now. You'll have to do some reading on it and understand what's going on in the first place. And then add some important features. So some of the things we've been looking for a while are Python wrappers. So because this is written in C, so it'd be good if we can call some of these things from Python, like we can do with NumPy. Convolutional layers. We had a team try to do that before, but it didn't really work. So feel free to try that again. It's doable. It's pretty doable. It's annoying, but doable. And just any other vital feature that you think neural network library can have. It's nice to add your stamp to this kind of perennial project we have here. CNN debugger. This is an interesting one, especially if you're more on the software engineering side of this. So create an add-on for TensorBoard or a standalone app. You can either use what TensorBoard already has or come up with your own thing that will attach to a running model, whatever that model may be, as a neural net, and it's going to put out a bunch of information to the browser. So probably just open a port and send out a web page, basically, that can act as telling you what's going on with this model. And this should include activation maps. This can include saliency maps. This can include a little plot of the loss that's going on. Just a really good way to see what's going on inside of the CNN. For this one, you'll definitely be activation and saliency maps, but all sorts of other stuff would definitely be pretty good. Let us get an idea of really what's going on inside of a currently in the process of learning CNN. This is a new one. This is a new idea, and this was forgot to change that. Yeah, I wouldn't use Arduinos for this, but you can, I guess, if you want to try. But yeah, try this with Raspberry Pis instead, especially because I think you guys have those already from 250. So this is a neural net control system. The idea here is you're going to create some sort of physical machine. This thing should be taking inputs and from sensors or buttons or whatever, and it should have outputs that are some sort of kinetic movements. Maybe lights are lighting up, maybe an arm swinging around. You can make a robot. Robots are good. That'd be super cool. But the important thing is, once you have this built inside of your Raspberry Pi, go ahead and train a neural network to map those inputs to outputs that you want. And the way that I would do this personally is don't train it on the robot. That's not going to work very well. Train it on your laptop on a simulation. Write a really quick simulation just on, and I'm not talking about like simulating the physics of the arm or anything. I'm talking about like simulating the actual inputs and outputs you want to go to what. So like if you want the arm to go down, then the signal that moves the arm down should go out when you push the button that should do that. So write it there, train it there, test it there, and then import that all over to the Raspberry Pi with the saved weights and everything, and see if you can get it to run on that machine. That would be super, super cool because now you have basically a neural net robot thing. Um, Really neat little idea. Um, I think it's very doable, especially if you are pretty good at the hardware side already, or if you've done some robotics in the past. Um, I like the idea a lot. It's a fun one.
By the way, that just made me think of an interesting idea. Uh, I was thinking recognizing ad URLs to try and block them.
Recognizing ad URLs? Oh, yeah. That's
Because I know
doable.
that like Google will randomly generate them and such. So it might be possible to somehow teach an algorithm to match against that and as well as predict what other URLs may look like for other ad services.
It's possible. If they're randomly generated, though, the neural network's not going to be able to do that. Neural nets, unfortunately, they are kind of stonewalled by randomness, like true randomness or anything really close to true randomness. Um, I mean, it's possible that Google's using a really bad RNG for it, but assumedly they aren't. Because the neural net, what it's doing is it's picking up on little bits of variance, little bits of non-randomness, and that's basically what learning is. Which is, I have a whole thing on this when we get to our ethics lecture. That's on how, in a way, you can almost think that crypto is almost the hard counter. Not crypto, the currency, but cryptography is kind of the hard counter to AI in a lot of ways. Um, but yeah, I think it'd be a cool idea to work on like a URL recognizer sort of thing. But if they're using randomness, you're not going to be able to beat that, unfortunately.
Would it be possible to use a probabilistic, uh, like the? I know we had the autoencoder thing, which had the distribution as part of it. That was probabilistic. Would it be possible to use something like that?
Yeah, if they're using a bad RNG that isn't actually random, then yeah, that would be doable. But if it's actually random, there's nothing you can do basically. If it's real random, then there's no inputs basically. There's no real useful inputs.
Okay.
Um, though again, maybe Google's using a pretty bad random number generator. I'm not sure. It's possible. Um, After that, though, we have implementing a paper. So this is probably our most open-ended one besides a custom project. This is go look for a paper, something preferably in the last 5 years. That's a neural network paper, and it should be somewhat obscure. It shouldn't be like, all right, I'm going to re-implement GPT. Good luck with that. That's not going to happen on our machines. Um, but find something kind of obscure, something doable, something that you can implement the algorithm of, and go ahead and make it. And then see if once you have it done, you can actually get it into the form of a nice tested open source library so that that one specific little algorithm now everybody has access to in a really easy way. Um, if you ever want to be a research engineer, very specific job, but if that's the kind of job you'd be interested in where you're not quite theorizing to make the algorithms, but you're implementing the first kind of prototypes of these algorithms, this is the project for you because you're hopefully creating one of the first uh, real implementations that's easy to use of this algorithm that you're finding. The next one, I will fully and readily admit, that this is partially so I have less work to do in the future, but it's a cool idea and it allows you to kind of leave a mark on the class. Um, so in this one, re-implement all the labs that we did so far, except instead of using Keras, use PyTorch. Um, Obviously, the parts of this that don't use either, you can just keep the same. For instance, like the custom neural net from Lab 1, you wouldn't be touching, really. You would, you could change it from being NumPy tensors to PyTorch tensors. That'd be pretty useful. But really, it's the main thing is getting everything else transferred over. And if you do that, first of all, the thing that's useful out of it is that now you've learned PyTorch, which is a very interesting, in a lot of ways, much easier framework and much more dynamic. You can do a lot more with it sometimes. Um, but the other thing is, if you do a really good job and we like what you have, and it's nicely commented and all that, we will use it as skeleton code. We'll rip out some of the parts that are we'd like people to implement, and we'll use it as skeleton code in the future for this class. We'll still have the Keras versions if people want that, but we'll give people an option for PyTorch if they want. So that's a good one. That's a nice little change of pace. And then the last two, these are if you really have a chip on your shoulder. This is for something you really want to try some difficult stuff. So first, I call this one outside the box. This is take an autoencoder and have your input image be a center crop of the output image. So basically what you're doing is you're training the autoencoder to guess, to predict what is going on outside of the image that you're showing. And then once you've trained it that way, put some pictures in there. See what happens. See what the neural network guesses happening outside of the picture. What might end up happening is you end up with a picture that just ends up with noise outside and like a weird shady background. That's possible. But you also might end up with it trying to just like come up with weird stuff going on outside, which could be really cool. And if you do this, you should probably use a VAE. You can use or a GAN. I said perhaps an autoencoder here. A GAN works if you want to try it that way, or a VAE would be pretty good. That was what we were talking about, the probabilistic. So yeah, that's a good one. And I said I used here 32 by 32 going up to 64 by 64. You can change that however you want, but that's just the suggestion.
That is different from upscaling, right?
Yeah. So this isn't going to be taking an image and making it bigger. This is going to be taking an image and trying to guess what happens outside. So this would be taking the picture of me here in front of my pirate flag and guessing what my apartment looks like over there, where you can't see off screen. So that could be pretty cool. And then again, the way you're training this is by first giving it these images that are, what happens outside because you're using the input. You're actually cropping it from the output. And hopefully it'll start to kind of just give some guesses as to what's going on outside. That could be pretty cool. And again, I don't think like if you just do it with a normal autoencoder that's not variadic, I think it's not going to work super well. So try with a VAE. That would help a lot. And our last option here, probably one of the more difficult, but also really, really cool. 3 generators. So there's something called progressive neural networks. This is something that I've been working on quite a bit. My thesis is actually to do with this somewhat. Here's the original paper for that, and here's an article I have on Towards Data Science that you should definitely read also about that. Um, and what this allows you to do is transfer learning. So basically, you can take one model, one neural net, and you can take what it learned and apply it to something else on a different neural net. So it can take some of the knowledge from this one and give it to another one. And that means that you can learn, if you have similar tasks, you can learn to do them a lot quicker after you've done the first one, because let's take the knowledge from that one and bring it to the second one, take the knowledge from both of those and bring it to the third one, and you end up with better and better neural nets. And this is a way of doing that. So this project would be reading about these progressive neural nets. You can actually use this library that I made called Doric. This is Progressive Neural Net Library. And use that library to create 3 image generators. These can be GANs, VAEs, whatever, that all transfer learn from each other and learn different classes. And then you could have like the first one. First, it learns to pictures of airplanes. Then it learns pictures of cars. Then it learns pictures of space shuttles. And it's going to use what it learned about reconstructing the one image to apply that to the others. And hopefully what you'll see is the amount of time it takes to train the first one is going to be a lot more than it takes to train the last one. The last one's going to train a lot faster because it's already using all this information. And yeah, you can definitely ask me for help if you're working on that one because, again, studied this for a while and I wrote the library. So yeah, that's it. Those are our options. And of course, you can pick a custom one if you want. You have, I put on all of these how big I suggest each group should be for them, but you can go outside of that if you want. And that's about it for the final project. I'm happy to go over to the style transfer slides now. But any questions on that?
Hey, Max, really quick, about the due date for Lab 4.
Yep.
You made a Piazza post, I think on Sunday, actually, that says it was going to be extended. You're going to be making it due November 2nd, which is not Friday, I don't believe.
Did I say that?
Monday. Yeah.
Oh, all right. Let's go by that then. It's extended to November 2nd. I forgot I made that Piazza post.
Yeah, it says, hey, all. Here are the mini lectures from 1021. Also, I realized I didn't announce Lab 4 on Piazza yet. I was thinking of extending it anyway, so I'm making it due November 2nd.
Oh, yeah, that's because I didn't, for the people who can't attend the class. Okay, yeah. Oof. Okay, yeah, it's November 2nd then, it's Monday. Yeah, that's fine.
Okay, just wanted to double check.
Yeah, good stuff. Any other questions on final project?
Not really. I'm just excited to brainstorm some ideas for it because I'm already having some cool things I want to try out.
Oh yeah, there's a lot of good ones here. And this, I like that people can do their own thing if they want. You can figure out kind of your own niche that you want to work in.
Yeah.
I will say, last semester, I was a little underwhelmed with the final projects last semester. And a lot of that was probably to do with COVID starting at that time, so everyone was all freaking out. So please, everyone, do better than last semester. Only because it's kind of nice to have like more interesting, but not that they were all bad. Some of them were really good, but like it was definitely a small dip in quality that was noticeable from people adjusting.
Mm-hmm.
Um,
Oh, you know what I just thought of? The Even if I can't do the URL ad blocking thing, because I was wanting to try and apply that to Pi-hole on my Raspberry Pi, but it could be possible to classify URLs based off of the general content that would probably link to, whether
that's
it's
very
shopping
possible.
or
Yeah,
and
if it has like because like if it has certain words inside the URL, it's going to be more likely that it goes to different
yeah.
things. That's very possible. Um, all right, so we'll move on from this at the moment. Um, let's go over to our style transfers. So these were cool. Again, very proud of all of you for these. Um, these were really good this time around. Very happy with how they turned out. If I think I got everyone who submitted an image to me in this show. If I didn't, feel free to call me a butthead, and then do that before the end of class, and then you can share your screen and show yours. But I think I got everyone's. Pretty sure. Not 99.9%. Why does my phone keep yelling at me? I don't like it.
It's me, Max. I'm announcing my presence. Sorry,
Anthony,
everybody. Chipotle was apparently a little bit more important. I got my burrito, thought I was forgetting something, and then I realized I was forgetting something. But I got here just in time with a burrito.
You sneaky boy, texting me while you're also in the chat.
You know how it is.
I've been sneak snuck again.
I suppose that's one way to say it.
It's a dumb way of saying it, but yeah. All right. So, I'm going to start off here with this guy. I like this one. I'm pretty sure this was with Starry Night as the style image. I think for the first bunch are just Starry Night because that's the example I give a lot of people use that, which is a good thing because I really like that image. And this turned out nice. This does look pretty close to hand painted. So yeah, it's really cool, little puffin guy. Especially, I like that what almost happened here is the background's almost accidentally blended with his little white patch here, so it looks like he's fading out, which is sort of a painting thing that could happen. So yeah, it was really cool. I really like how this turned out.
It vaguely reminds me of like the lobes on a brain, like the little ridges.
Yeah, the background swirls do.
Yeah.
Yeah. So here's an content image. This reminds me of Teldrassil from World of Warcraft. If anyone remembers back in the day.
I think that's. Oh, sorry.
Yeah, I don't know what game it's actually from or what world it's from, but
it looks like a depiction of the Yggdrasil from Norse mythology.
Oh, it does look like Yggdrasil, and yeah, you might be right there.
It looks like Yggdrasil leads all the way to the Death Star, even.
Yeah, it's the
really
main
do have
Viking
all of
realms.
those realms in there.
The main Viking realms. You have Mundus and Valhalla and the Death Star.
All the way to Star Wars. It would go to galaxies far, far away.
Oh yeah. But this is what happened with that, and that's cool. Look at that. That's
fantastic.
I think that this one and the next one, I have my several little awards I like giving out. This gets the award for best capturing of the style, because this looks a lot like the style of Starry Night. Same with this one. Content image, style or stylized. These two get their award for that, I think, because this captures that style so perfectly. I love it. This one's also quite good. I think also Starry Night, but this is Statue of Liberty. This one, I like what it did, and I captured the style really well. I'm wondering if either it was the content image was colored in a certain way that made it this sort of weird pinkish tone, or whether there was a thing in pre-processing. But either way, it kind of looks it's treading the boundary between looking painted and looking not painted, which is really cool. It's a neat effect that's happening from it. Same with this one. Like it looks like a painting up to about here, and then it feels like it's almost not a painting, but just barely not. It's really cool. Again, it's kind of having this weird coloring artifact though, so I'm wondering if that was a thing with deprocessing, or whether it's just these are very warm colored paintings or warm colored images in the first place. Here we have a temple, and same thing. This looks hand drawn. This looks like someone with colored graphite went in and drew this out, and that's awesome. Like it's a subtle one, but it looks really hand drawn, and I love it. This one went very well. I believe this is somewhere in Germany. And the normally I wouldn't think that the style of Starry Night would fit with a very bright kind of nice image like this as well, but it turned out very well because it's kind of swirly but it still keeps the warm colors. It feels like a nice summer day in this German canal town thing. Now we got some very interesting images of mushrooms and I think leaves, yeah, that end up with this almost kind of squarish, brushy pattern going on. Again, this is just Starry Night still, too, so you can see how the one style can kind of branch off.
That one was not Starry Night, actually.
Oh, this was not Starry Night. Which one was this?
That was an image I cropped myself out of one of my desktop backgrounds.
Oh, but I mean the style for it, though.
Yeah, that's what I'm saying. That's what the style was.
Oh, gotcha. Yeah, it looks like it looks quite a lot like a kind of squarish, brushy sort of thing going on. It's really cool. Same with this one. So here's a content image, and this one has applied two different style images, so we can see what the different what they each look like here. And we have this kind of like corporate, blocky looking thing that reminds me of there's one skyscraper I've known in Chicago. And then we got this explosion of color that looks really cool. And here's this one ended up with like I think it turned it into being underground almost, because it turned the sky into looking like rocks. Really neat sort of thing going on here. And then I think it applied again on top of that this other image. And now we got these bursts of color in here. And it's really a neat sort of thing now. It went from something that looks very real, very much just a picture taken, to something that's really surreal and strange and neat sort of thing.
Wait, so those were applied on top of each other?
I don't know, but it looks from the two.
Yeah.
Whoever
cool.
made this, if you want to comment, I've been keeping everyone anonymous, but if you want.
I just did it separately.
Okay, so they're two separate ones. Okay, I guess the sky just was ready to be a canvas easily.
I really don't know why the sky was focused. It just did like that.
Yeah, well, it is a good
Looks
result.
Cool.
Yeah. We got this adorable fluffy dog, and we have geometry. And the second I saw that this was going to happen, I was really worried because I thought we'd have a very geometric dog. And we kind of do, but it's still cute. It is a cute geometric dog. It looks kind of flaky. It looks like a flaky geometry dog, but I like it. And it's a very interesting style to use because it's hard to take a very super abstract style and put it in the real world. So I would say this is probably the award for this picture is most ambitious style, and it went pretty well. I think the results are pretty damn good there. So here, I think this is the Forbidden City, if I'm correct, or part of the Forbidden City. And we're combining this with the Spider-Verse. And this is an interesting style to use, too, because it's almost like a much more realistic version of what you would see in comic books back in the day. Like, you even have this kind of, like, spotty sort of thing going on in parts. It's a really interesting style to use. And it ends up looking a little bit okay. This might just be me, but this feels like something from Avatar: The Last Airbender. Now, this feels like something from Ba Sing Se. If anyone's watched that show, great show.
Yeah.
I mean, it might be someone in Ba Sing Se on acid because the sky is nuts, but I like it a lot. It's very interesting sort of thing. Here's a crazy style image. Again, this is probably one ties for the super ambitious style image reward. And we've applied it to the arch. Very cool. Applied it to the Statue of Liberty again. Also very cool. I think I like the Statue of Liberty version a little more with this particular transfer. This one. So I love this picture, by the way. And we are transferring it again to the arch and the tower. This arch, I would have this in my house. This just looks awesome. It looks otherworldly and strange, and a little like it's something you would almost find in like a cave illustration almost. It's really cool. I love it. I really like this one. This is the award for image I would most likely hang up in my house. The Mandalorians are awesome, so good stuff. The style transfer got really dark here. I don't know what happened with that, but it's clearly worked because this I think was also the Starry Night. So the transfer actually went really well, but it ended up being really dark. So again, I wonder if this is a pre-processing thing or like a post-processing thing, or if that's just how these two images combined. Interesting sort of thing, though. I like the go at it.
Yeah, I was having a real problem with the brightness drop in these images.
Yeah, that can happen. I remember we had another guy who had a problem like that last semester, I think, or maybe the semester before that. I don't know if that's something with deep processing or if that's something with just certain images do that. I'm not sure. So we got Eiffel Tower. That looks cool. The Eiffel Tower has now become in some sort of storm world. Good stuff. The sky particularly looks super painted here, which is nice.
That looks like the scene from Halo with the big thing that they dug up.
Oh, you're right. That looks like the Eiffel Tower now looks like the ship, the Forerunner ship.
Yeah, the key ship.
Yeah. I was just replaying that recently. Okay, so here we have a bustling city painted in sort of a brushy sort of style. And then this house. Tell me, is this house from Harry Potter?
No, that's a place in France.
Okay. Was the place in France used in a Harry Potter movie? Because I feel like in one of the later Harry Potter movies there was a house like this, but at the same time, I don't remember for sure because I only really watched.
It's entirely possible. I know that location, whose name escapes me at the moment, has been used in the filming of films in the past, so it would not entirely surprise me.
Okay.
Also, that style image on the right side is also what I used for the leaves and mushrooms.
Oh, is that okay? I gotcha. Yeah, that makes sense. It's the brushy sort of style, and it turned out pretty well here, especially on the sky again. I'm finding that the sky in a lot of these has been very, very good for the style transfer. Details it can have trouble with, which makes sense because it's not even a trained neural network. It's a neural network that was trained on something else, but it does a really good job still, especially in this upper like half of the image, and even down here. Like you look at this tree, that went really well.
Yeah. It even has the little specks of light like in the style, which looks
Yeah,
pretty cool.
yeah. So again, we're applying this image, brushy image, and that works pretty well. I think the house one went a little better, but then again, like the side here, it looks pretty well transferred, so that's good. Got a few more here. We have these ones. I don't think I actually included the content image for, but this is the same image in 3 different styles. This one's definitely Starry Night, but you can see the differences there, which is really cool. And I like this idea of comparing the different styles of the same image. And same thing, these are the same 3 styles on the same one image. So we got there, there, and there. And you can see, like, one thing I love is the trees. Trees here are not very prominent. They're kind of fadey. Then they get more vibrant. It's almost like spring. And then it gets kind of into like the color shift so much. Like you have the very red here, and then the red goes away. It's really cool. And again, same idea. 3 images of the same thing, but with different styles. Very cool. And this one, okay, so this
Max,
well, yeah.
Max, I will have to go now. Guys, you did a great job with the images. I think that
Really good job.
Yeah, your work has been one of the best on all the semesters that we have had in class. Congratulations.
I agree completely. Very good stuff.
Okay. Well, I will have to go. So Max, maybe we do you remember we have been adding some of those images to the website. I think that would be nice to add them there.
I already have them up.
Perfect, excellent, great. Thank you. Okay, talk to you.
Yep. See you later.
Next week. Bye bye.
Bye bye. So this one gets the reward for most creative style transfer in how it functionally. So this is not the content image. This is the style image, and it is a picture of the city looking out of assumedly a window here covered in rain. This is the content image. And when we apply the style transfer, we get what looks like a rained out Purdue through a little glass window here.
That looks fantastic.
That went really well. I love the idea behind this because I remember first semester I taught this class, I saw something interesting from both Anthony and Sri. They both did one where they took I know Sri did this one. Anthony did the Anthony, you did the
I did the Ed Nettie house.
Ed Nettie, yeah.
The house looked like it was from Ed Nettie.
Yeah, that was really cool. And Sri did one where he actually had one cartoon that was going to, or one cartoony image that was style transferring to another cartoony image. So it was like a comic book in a different style. So that was cool, but this is quite the opposite of that. This is 2 real-world images that we're using the style transfer on, and it totally worked. Like this looks quite a bit like a blurry image. Like this looks like someone took a picture through a window of a bus or something at Purdue, but they just had like a kind of crappy camera when they were doing it.
With the way the coloration shifted, it looks almost as if it were taken like
in movement
long ago, with an older camera.
Yeah. But even like the artifacts on this are really nice because you can see not only the raindrops, but it kind of has the through a window sort of glare going on too, and that's really something. So this, I think, this is the last one because I just wanted to show off kind of what you can do with doing this in a different way. So yeah, that's all I have for today. Good luck on your final projects and getting those set up. Try to get those charters into me by next week. Feel free to use the Piazza tool. It's already open for you. And any questions, go ahead and ask, and I should be able to clear those up. It should be a good project. If your style transfers are any indication of your guys' ability, then I think you'll do very well in the final project too. Come up with some cool stuff.
Oh no, we're missing some.
What?
Somebody just messaged that their transfers didn't make it in.
Oh no, did I miss one? Oh no. Who did I miss? All right. Oh, I'm sorry. I didn't see yours in the emails. Okay. So, and then we had some questions here on other stuff. Okay, I'll answer those questions in a bit. But first, Minju and Michael, do you want to show off your style transfers then? I apologize again. I must have just missed them in the emails. Are you sure? We'd love to see them if you want to show them off. Yeah, pull them up there. I'll stop sharing my screen. I might need to make you guys present. Is it? I think you should be presenter still in there or something. Ooh.
I guess I'll share.
Cool.
Real quick. Okay, so pardon my very messy desktop.
That's fine.
This is the style, this is the content, and this is the style transferred image.
Oh wow, that's awesome.
That's my cat.
Yeah, that did a really good job there. It's especially with the colors, it seems like it really got the idea of like kind of an almost like shaded sort of thing going on with the colors. I like that a lot.
Yeah, I'm pretty surprised that it actually kept the edges and stuff. I thought it was gonna be so abstract I can't recognize it, but yeah, I'm glad it worked.
Yeah, it did a great job.
Thank you.
All right, Michael, you want to do yours? Michael, you there? Oh yeah, go ahead. In the meantime, I'll try to answer some of these questions up here. So, yeah, we talked about that. Yeah, we'll make that be Monday. So we had. I think this is supposed to be just a summary for all of these. Yeah. The three generators That's going to be tough to understand until you actually read the article for that. But the basic idea is making 3 GANs or 3 autoencoders or whatever you're going to use for generation, and letting them, in a way, learn from each other using this process called progressive neural networks. So I probably wouldn't pick that one unless you really want a challenge and you want to learn about transfer learning specifically. That's kind of its own area. Yeah, the rest of these are pretty spot on.
We used the same style image.
Oh, for which one?
Oh no, Michael's sharing his result. And
Oh, I'm not
I
seeing
just
it
realized
yet.
that we use the same image for style.
Oh, cool. I'm not seeing it yet, though.
It's there.
Yeah, it's there. We can see it.
Oh, why isn't mine seeing it?
I cannot see as well.
Maybe I have to make him a presenter? Oh, where's... Goes here.
That's weird.
Huh. No, he's a presenter.
I especially like your the top style transfer you have, Michael. That looks very cool.
Yeah, man, I wish I could see it. Can you post it in the chat, maybe?
Are you able to switch your focus, Max?
I don't think so.
Okay. Because I think you can focus on people by clicking on them. I wasn't sure if you had done that on accident.
Here. No, it's I'm seeing everyone. Or at the 9 by. Oh wait, I think it's coming up. Wait, no. Spotlight, maybe. Is that?
Wow, there actually aren't all too many people in the meeting, are there?
Yeah, not really. Oh, nice. Here we are. Oh, wow. Yeah, this is very well transferred. Nice. Cool. Yeah, good stuff. All right. Well, I think we're good then. I don't have anything else for today. If you want to figure out about who's going to work with who on the final project, again, you can use the Piazza tool, or feel free to just right now talk about what you be interested in doing. I'm probably going to jump off of here because I would like to eat something. But other than that, unless you have any other questions, I will see you guys again next week. Peace. Oh wait, question?
One final question. This is about the GAN lab.
Yep.
Do you have any idea of what could be causing the output images to have weird vertical lines where nothing is changing? Where it's just like a whole column of pixels.
So, I'm not sure exactly. It could be the...
Is it colored?
No.
No, it's not RGB.
This is just MNIST.
Right.
So it could be I think we were talking about this before there, the discriminator's learning a lot faster than the generator, so the generator just can't keep up. That's possible.
The thing is, I'm seeing things change and I'm seeing it get closer. It just happens. Here, I can put an image into the chat to show what exactly it looks like at the moment. But it winds up looking sort of like that, where the outside is just padding, but you'll see there's like vertical bars going down where it just kind of got stuck. Specifically the gray, the black and the white areas changed a little bit.
So yeah, which label is that for?
This is coat.
Okay. So one thing you might want to check to kind of get a better idea of what's going on here. Go ahead and I think so. There's part of the lab that is you have to make plots for the loss values for each of these two things. Make sure that's implemented, and then you can actually see, or you might be able to see, hopefully, if the discriminator is learning too fast. Because what you can see then is the loss of they'll both start going down, but then the discriminator goes down a lot, and then it levels off really quick. And what might be happening there is the discriminator just kind of figured it out, and it doesn't really need to improve anymore. And when that happens, the generator's just not really going to learn as much because it's not going against a adversary that is learning with it. It's going against an adversary that's just going to crush it.
Okay.
And then the way to fix that, if it ends up being, if you're seeing that loss happen that way, is doing some form of either ratio training where you're training this 2 times and then this 1 time, or it could be even like a learning rate thing. Like you might want to make the learning rate much, much smaller for the discriminator, so it just takes longer to learn. There's a few different ways to do it, but definitely keep in mind that that's a fairly possible option.
Okay. I will look into that then.
Good stuff.
All right. Thank you.
No problem. All right. I'll be getting going then if there's no other questions. Great job, everyone, and see you next week.